Let's see question number 14. Sides AB and AC and median AD of a triangle ABC are respectively proportional to sides PQ, PR and median PM of another triangle PQR. Show that triangle ABC is similar to triangle PQR. Okay, so this question is somewhat similar to question number 12 here. In question number 12 we have here AB and BC. Here in this case it is AB and AC. So sides AB, AC and median of a triangles ABC are respectively proportional to PQ, PR and median PM of another triangle PQR. And now we have to show that triangle ABC is similar to triangle PQR. So let's draw the figure for this. Question number 14. Let's call this ABC and another triangle here. And let's call this PQR, and we have medians of this triangle ABC. Now let's take a midpoint here and join it to the opposite vertex. Now this is median, and again we'll take the midpoint here and join it with the opposite vertex. Now this is the median of the second triangle. So we have two triangles ABC and PQR. Here to prove this triangle ABC similar to triangle PQR. Now here the ratio of AB and PQ is equal to the ratio of AC and PR is equal to the ratio of AD by BM. That is what proportional means. So that is what the question has given. Now what we will do here is we will try to get that this angle A and angle B equal. So let us see how we can get these two angles equal. So first to do that we need construction here. So let's write here construction. Okay, let's produce AD to a point here. Let's call it E, and such that AD line and this DE line are equal in length. So for example, if this 5 centimeter and then this is also again 5. So after that we will join this and this, and here also let's produce this PM such that this and this are equal in length, and let's join this and this. Okay, let's call this PQRMS. So let's write AD and PM are produced to AD and PM are produced to E and S respectively, such that AD is equal to DE, and PM is equal to MS. And also we join BE, CE, QS and RS. Also BE, CE, QS and RS are joined. Now proof. Let's recall a property of parallelogram which we're going to use here. So in class 9 you have learned that the diagonals of a parallelogram bisect each other. So this is one diagonal and this is another diagonal. Now these two diagonals bisect each other, which means the point of intersection of these two diagonals is the midpoint of this diagonal and also this diagonal. That means if this is 12 centimeter, then this is 6 centimeter, 6 centimeter, and if this is 8 centimeter, then this is 4 centimeter, then this and 4 centimeter here. But this is one very important properties of parallelogram. Here, see, this is a quadrilateral now. Now in this quadrilateral, these are the two diagonals, and in these diagonals, D is the midpoint, because this AD is a median, so D is the midpoint. So this and this are equal. Now, and again by construction, this AD is equal to DE. What we have now here is the diagonals bisect each other. Now since the diagonal bisect each other, this quadrilateral is a parallelogram. This quadrilateral is a parallelogram. So here we have BD is equal to DC, BD is equal to BD is equal to DC. Since D is the midpoint of BC, midpoint of BC, and AD is equal to DE. This is by construction. By construction. So what does this implies? This implies that this BABEC is a parallelogram. The reason is since the diagonal bisect each other, since the diagonals bisect each other, Now since ABEC is a parallelogram, the opposite sides are equal. So AB side is equal to EC, opposite sides, and AC is equal to BE. AB is equal to CE and AC is equal to BE, because these are opposite sides of parallelogram. Now in the same way we can prove that this PQSR is a parallelogram. So here we don't need to show that, so we will just write here similarly we can show that PQSR is a parallelogram. Now since this PQSR is a parallelogram, again the opposite sides are equal. So PQ will be equal to RS and PR will be equal to QS. So PQ is equal to RS and PR is equal to QS. Now this is opposite sides of parallelograms are equal. Opposite sides of parallelogram. Now what we'll do is we will use what is given in the questions. So in the question it is given that sides AB, AC and median AD are proportional to side PQ, PR and PM. So this is what is given in the question. So it is given that AB by PQ is equal to AC by PR is equal to AD by PM. Now here let's call it 1. Now this one, AB by PQ is equal to, now AC, what do we have here is AC is equal to BE. So in place of AC we're going to replace it with BE, and in place of PR we're going to replace it with QS. PR we're going to replace it with QS is equal to AD by PM. And here there is something we can do here. This AD we can write half of AE. AD we can write half of AE, since this is also half, this is also half of AE. So here I'm going to write here, this one I'm going to write half of AE, and this denominator, this BM here, PM we can write half of PS, so half of PS. So just cut this one, so now half and half you can cut. So what we got now is AB by PQ is equal to BE by QS is equal to AE by PS. Now let's see what is the use of this. Now here in triangle ABE, this triangle, and this triangle here PQS, ABE, this one and this one, AB by PQ, the ratio of these two sides, AB by PQ, the ratio of these two sides is equal to PE by QS. It's equal to PE by QS, here the ratio of these two sides, and is again equal to AE by PS, again equal to AE by PS. So what we got here is the corresponding sides of these two triangles are proportional. That is the ratio of this and this is equal to the ratio of this and this, and the ratio of this and this. So therefore by SSS similarity, these two triangles are similar. Therefore triangle ABE is similar to triangle PQS. This is by SSS similarity. Now why do we need to prove that these two triangles are similar? What is the use of that? Now I'll show you here. Now since these two triangles are similar, this angle, this angle here and this angle, now we can say they are equal. Now they are equal. So let's say this is angle 1 and let's say this is angle 2. Now this angle 1 and angle 2 are equal because just now we have proved that these two triangles are similar. And similarly here, this angle and this angle are equal, and this angle and this angle are equal. But we will be using only this, since our main objective is to prove that this to get that this angle and this angle equal. So since these two triangles are similar, this angle is equal to this angle. Angle 1 is equal to angle 2. So we're going to write here, therefore angle 1 is equal to angle 2. Now this is one very important things that we got here. So let's call it 2. And similarly we can prove that this triangle ACE, that is the right side triangle here, and this triangle are similar. These two triangles, triangle ACE and triangle PRS. So we will not show that, we will just write similarly. It can be shown that triangle ACE is similar to triangle PRS. Now once we got that these two triangles are similar, we will say that this angle and this angle are equal. So let's say this is 3 and this one is 4. So now here we have mentioned here these two triangles are similar, therefore angle 3 is equal to angle 4. Now this, let's call it 3. Now let's add this 2 and 3. Adding 2 and 3. Adding 2 and 3. Now look, let's add this left side and left side, that is angle 1 plus angle 1 plus angle 3 equal to angle 2 plus angle 4, angle 2 plus angle 4. So now angle 1 plus angle 3, angle 1 plus angle 3. Here angle 1 plus angle 3, we get this big angle, angle BAC. Angle BAC, angle BAC equal to angle 2 plus angle 4, angle 2 plus angle 4, we get angle QBR, angle QBR, angle QBR. This is what we have been trying to get. The reason why we are doing all this above step is to get this one. Now finally we can compare these two triangles, that is triangle ABC and PQR. So let's see what are equal now. In triangle, so we're going to continue with this after this. So in triangle ABC and PQR. Now we're going to write this one, angle BAC is equal to angle QPR. You can write here shown above, and we're going to use this equation 1 here. We're going to use this one. So we will use this, we'll take this one, AB by PQ, AB by PQ is equal to AC by PR. This is from 1. Now we are going to look at the figure here. Now look at these two triangles, ABC and PQR. Now this BAC and QPR are equal, which means this angle and this angle are equal. And AB by PQ, the ratio of this AB and PQ is equal to AC by PR, AC by PR, the ratio of the other two sides. So we have here this angle equal, and the ratio of this side and this side, and here this and this are equal. So therefore by SAS similarity, therefore by SAS similarity, this triangle ABC is similar to triangle PQR. So this is the proof, hence proof. Now we'll move on to the next question, that is question number 15. A vertical pole of length 6 meter cast a shadow 4 meter long. Here there is a vertical pole here, and the length of this vertical pole is 6 meter, and it is casting a shadow 4 meter long. Here the length of the shadow is 4 meter, and at the same time a tower casts a shadow 28 meter long. Okay, there we have a tower here, and it casts a shadow of 28 meter long. So now find the height of the tower. Now what we're going to do is we're going to find the height of the tower. Let's draw the figure for this. So we have a vertical pole and a tower here. So this is let's say this is the vertical pole, here this is the shadow, length of the shadow, this is the pole here, and this is 6 meter, and the length of the shadow is 4 meter, and we have a tower here. Let's draw the tower like this. Let's suppose this is the tower, and the shadow of this tower be this line. Now this is 90 degree, this is 90 degree. Now the length of the shadow of the tower is 28 meter. So let's complete the triangle here. So let's call it ABC, and this one is DEF. So let BC be the height of the pole, and AB length of the length of this shadow, length of its shadow, and EF height of the tower, so therefore now AB, then this PC is 6 meter, and AB is 4 meter, and DE is 28 meter, and EF is what we're going to find out. EF we don't know, so let's call it X. Here there is something called angular elevation of the sun. I'm going to show you what that is. Now let's say this is a tree here, sun here. Now at this particular point of time, let's say the length of the shadow of this tree is this one. Now if we complete the triangle, we will get like this. This is 90 degree, and the angle which is made by this shadow on the ground and this line here, this is called angular elevation of the sun. This is angular elevation of the sun. So at different time, the angular elevation of the sun is different. So if for example the sun is here, so when the sun is here, the angular elevation will be less. So this is the sun rays will be coming like this. So this line actually is the sun rays here, and here this angle is the and here this angle is the angular elevation. At this instant, the length of the shadow is longer. So at the same time and at the same place, the angular elevations of different objects, irrespective of height, it's all the same at the particular time. Here, now here this is shorter, this is taller. Even though this is shorter and this is taller, angular elevation of the sun remains the same. So here in this question, these two takes place at the same time, which means that the angular elevations is the same. That is, this angle and these angles are equal. So here this is 90 degree, this is 90 degree. Now this and this are equal. So we have two angles of this triangle equal to two angles of this triangle. Now we can say that these two triangles are similar by angle-angle similarity. In triangle ABC and triangle DEF, angle B is equal to angle E, since each of them are 90 degree, and angle A is equal to angle D. This is angular elevation of the sun, angular elevation of the sun, elevation of the sun. Now therefore, by AA similarity, these two triangles are similar. Triangle ABC is similar to triangle DEF. Now this is by AA similarity. Now since these two triangles are similar, the corresponding sides are proportional. So AB by DE will be equal to BC by EF. AB by DE is equal to BC by EF. So this is implies that. Now let's cross multiply this. You get here 4x is equal to 6 into 28, and here dividing both sides by 4, 6 into 28 by 4. Now let's cut this. 4 ones are 4, 4 sevens are 28. Now what we got here is x is equal to 6 sevens are 42 meter. So this tower, the height of this tower is now 42 meter. So you have to say here, therefore the height of the tower is 42 meter. Now this is question number 16 here. If AD and PM are medians of triangles ABC and triangle PQR respectively, where triangle ABC is similar to triangle PQR, prove that AB by PQ is equal to AD by PM. Okay, so let's see how we can prove this. And in this question, figure is not given, diagram is not given, so we're going to draw. We will try to figure out how to draw this. Triangle ABC, triangle ABC, A, B, C and PQR. PQR. Now we have medians. Let's take the midpoint of BC. this is D, and join it to the opposite vertex. And again, let's take the midpoint of this QR. This is M. Now join to the opposite vertex. This is median. Now this is question number 16. To prove is AB by PQ is equal to AD by PM. AB by PQ is equal to AD by PM. Now proof. Now in the question it is given that these two triangles are similar. Triangle ABC is similar to triangle PQR. So we can use the property of similar triangles. So we have triangle ABC similar to triangle PQR. This is given. Therefore, now since these two triangles are similar, this angle and this angle will be equal. Angle B is equal to angle Q. If two triangles are similar, then the corresponding angles are equal. That is, angle P and angle Q will be equal. This angle A and angle P will be equal, and angle C will be equal to angle R. But here we're going to take this angle here. Let's call this 1. And also, when two triangles are similar, the corresponding sides are proportional. That is, the ratio of the corresponding sides are equal. So AB by PQ will be equal to BC by QR equal to AC by PR. So here we're going to write AB by PQ is equal to BC by QR is equal to AC by PR. Now AB by PQ is equal to, now this BC, since D is the midpoint, instead of BC we can write twice of BD or twice of DC. So now we're going to write BD, twice of BD by, and this QR we can write twice of QM. This is equal to AC by PR. Now here 2 AB by PQ is equal to BD by QM is equal to AC by PR. Now let's call this 2. Now next step, let's see what are equal in these two triangles. In triangle ABD and triangle PQM, we have these two angles equal here, which is shown in 1 here. So angle B is equal to angle Q. This is from 1. And also here AB by PQ is equal to BD by QM. So now let's look at the two triangles. Now this angle and this angle are equal, and the ratio of this side and this side are equal. Also the ratio of this side and this are equal. So therefore by SAS similarity, these two triangles are similar. Therefore by SAS similarity, triangle ABD is similar to triangle PQM. Now since these two triangles are similar, the corresponding sides will be proportional. So the corresponding sides of AB is PQ. So therefore AB by PQ is equal to the corresponding sides of AD will be equal to PM. AD by PM. This is what we are asked to prove in this question here. AB by PQ is equal to AB by PM, and that is what we got here exactly. AB by PQ is equal to AD by PM, hence proof.